Hi everyone, I'm Nikita Gupta and I'm going to show you how to do one of the textbook problems that we were assigned. It's on page 64 and it's number 75. I'm part of the Period 6 Physics Honors class, and here's the problem. The question was, a pollution sampling rocket is launched straight upward with rockets providing a constant acceleration of 12.0 meters per second squared for the first 1,000 meters of flight. At that point, the rocket motors cut off and the rocket itself is in free fall. Ignore the air resistance. Find what is the rocket speed when the engines cut off. B, what is the maximum altitude reached by this rocket? And C, what is the time it takes to get to its maximum altitude? Now I'm going to show you how to answer all three parts of this question. Now here's a diagram representing the flight of the rocket. We know that it's going to travel 1,000 meters at an acceleration of 12. And then once the engine is cut off, it's going to travel up a little bit, and then it's going to come down. And it'll be in free fall. Now the first question's asking, what is the rocket speed when the engine is cut off? We know that the acceleration is 12. The distance traveled, or the final position, is 1,000 meters compared to the initial 0 meters, and the velocity right when the engine is cut off is going to be 0 meters per second. Using this formula, we're going to plug in our numbers and find out the final velocity. So we plug in 0 for the initial, 12 for the acceleration, and 1,000 for the change in distance. And then we get our final velocity as 154.9 meters per second. This is the velocity that the rocket is going to start at right when the engine is cut off. The next question is asking, what is the maximum altitude reached by this rocket? We know that the rocket traveled 1,000 meters in the beginning, and then once the engine was cut off, it traveled up more, and then it went down. So we want to know the maximum altitude reached by the rocket. Now, when the engine was cut off, it stopped accelerating, but it was in free fall, so the acceleration will be the force that the ground pulls the rocket, so negative 9.8 meters per second squared. We know that the initial position of when the rocket's engine was cut off was 1,000 meters from the ground. That velocity was also 154.9, and we want to find the final position. So using the same formula from before, we will plug in our numbers and we will get the final position of 2,224.2 meters. We have to keep in mind that that is the total distance traveled from when it took off from the ground, keeping in mind of the initial 1,000 meters. So the total of 2,224.2 meters. What is the time it takes to get to its maximum altitude is the next part that we have to answer. Now, since the first part we had an acceleration, it's going to have a different time than the time it took to travel this 1,224.2 meters. So that acceleration had 12, the final velocity was 154.9, and the initial velocity was 0. Using this formula and plugging in the numbers, we're going to get our time as 12.9 seconds. Now for the second part of our traveling of the rocket, we know that the acceleration was negative 9.8, the final velocity was 0, and the initial velocity was 154.9. And we want to know how long it took to travel from here to here. So the initial velocity 154, the maximum altitude it reaches a velocity of 0, and then that's when it'll travel back down. So using the formula and the numbers we have, once again, we will get our time as 15.8 seconds. Now those 15.8 seconds was the time that it took to travel this much distance. We still have to add the distance, or the amount of time that it took to travel these 1,000 meters. When we add up our total time, we get 28.7 seconds, and that's the time it took to travel this whole distance of 2,224.2 meters. Thanks for watching, guys, and I hope you have a better understanding of how to answer this question.